All right, so the next unit is on something called proportional reasoning, and it has to do with scale diagrams and scale models. All right, so yeah, so the first lesson in this unit is on scale diagrams. Okay. So something that's the kind of like the key concept in this whole unit here is something called the scale factor. All right, and the variable used for the scale factor is usually traditionally letter K. Right? So scale factor is going to equal the diagram measurement over the actual measurement. Okay, so this tells you how much or by how much the diagram is being enlarged or reduced. All right, and yeah, all right. So let's just jump into the first example here. Or actually, I think it's the only example for this lesson. All right, so one of the most like I guess traditional scale diagrams is a map. So, so basically what I did here is I just copied and pasted a map, and I'm just going to use this as the example. All right. So, the measurement from Vancouver to Seattle, all right, on this map is 4 centimeters. However, the actual distance is 230 kilometers. So, first question here is, what is the scale of the map? All right. So, all right, so the scale in this case, right, scale of the map, 4 centimeters is equivalent to, and usually they write it as a ratio. All right, so when I'm talking about a scale, you're going to write it as a scale. So every 4 centimeters on this map is equivalent to 230 kilometers. All right. Now, the thing here is that we have two different, I guess, measurements, right? We have centimeters and kilometers. Now, when it comes to scale, we can actually leave the units different. Right? However, part B here, which is a scale factor, we need to have the units the same. All right. So when you're asked, it's subtle difference what you're being asked for, but when you're asked for the scale of the map, you can leave it as two different units. Right? So 4 centimeters for every 4 centimeters, it's 230 kilometers. Now, the thing here is that we can actually reduce this, however. So if you can reduce the scale, so for instance here, notice that 4 I can divide by 2. 230 kilometers I can also divide by 2. Okay, so this scale here, we can actually reduce it to every 2 centimeters. 2 centimeters to 115 kilometers. Okay, so this would be the scale of the map. All right, so yeah. Now for part B, what is the scale factor? All right, so you might be thinking, oh, well, it's asking the same thing. It is, and it kind of isn't. All right. So the scale factor, when you're dealing with scale factor, the key thing here is that units must be the same. All right, so in this case, again, we're dealing with centimeters and kilometers. We need these to be the same units. All right, so so basically what I need to do is I need to convert the larger unit into the smaller, if that makes sense. So 1 kilometer is equal to 1,000 meters. Okay, so that's what the word kilo means. Kilo means 1,000. All right, so 1,000 meters is 1 kilometer. And so in terms of centimeters, right, there's 100 centimeters in a meter. Right, so to this, I need to multiply it by 100 centimeters per 1 meter. All right. So as it turns out, 1 kilometer is actually, you have 3 there and 2 more there. All right. So 1 kilometer is actually 100,000 centimeters. Okay. So in this case, now what I want to do is I need to convert the 230 kilometers, this measurement here that was in kilometers, into centimeters. So that in that case, we're going to go 230 kilometers, and I'm going to multiply it by 100,000. There's 100,000 centimeters in 1 kilometer. So 230 kilometers, that would be 230,000,000. All right, centimeters. So I just want to put the commas in the right place. All right, so as it turns out, yeah, 230 kilometers is 23 million centimeters. All right. So therefore, the scale factor, again, was the diagram measurement over the actual measurement. So in this case, the diagram, okay, so if I scroll it back here, on the diagram it was 4 centimeters from Vancouver to Seattle. I'm just going to write 4 centimeters up top here over, and then the actual distance is 23 million centimeters. And this is going to be, I'm going to actually divide these two. Okay, so let me just pull up the calculator. And I'm going to go 4 divided by 23 million. And we get, all right. All right, so this answer is actually in scientific notation. What would happen if I just enlarge it? It just gets bigger. All right, so that's 1 sec here. So move things around. All right, so so this will show up maybe in your calculator as well, where it says like e to the negative 7. So this actually means the number itself, I want to write it out, is 0.00000. I got to count the decimal places. So 1, 2, 3, 5, 6. All right, now 1, 7. Let's round it to 4. All right, so the way that I got this number here is because in green here, if I move the decimal over here, it's going to move over 7 places. Okay, so 1, 2, 3, 4, 5, 6, 7. All right, so notice that the decimal here is at 1.7. And if I move this over 7 places, because that's what this 7 over here indicates, that's how far I got to move it over. Yeah, actually, come to think of it, it would probably be easier. Let's write it again. If I start over here with 174, right around that, and they decided to move it 7 decimals this way, right? So I'll move it over 1, 2, 3, 4, 5, 6, 7. Yeah. So there you go. All right. Yeah, it is a little, it might get a little bit dizzy, but the key thing here is, yeah, so to go from scientific notation to the regular number, you got to move it over 7 decimal places. All right. Now, just a little note here. All right, so if k is between 0 and 1, then the diagram is a reduction. All right, so we're zooming out. Right, so notice here that, yeah, this number here is obviously less than 1, between 0 and 1. So this is what this map here is what they call a reduction, because the actual size got reduced, right? Obviously to fit into a map. All right. If k is greater than 1, then the diagram is an enlargement. All right, so basically you're zooming in, so the diagram is bigger than it actually is. Cool. All right, part C. If the measurement from Vancouver to Calgary is 17 centimeters, what is the actual distance? All right, so what it's saying here is, just go to the map here. If I was to measure from Vancouver to Calgary, and on this map it's 17 centimeters, we want to figure out what the real actual distance is. Right? So to do this question here, I'm going to actually go back to part A here and just use the scale. So what this does is that I actually don't have to do any conversions or anything. All right. So every 4 centimeters is 203 kilometers, or in other words, every 2 centimeters is 115 kilometers. Okay. So the way I'm going to set this up is I'm going to go every 2 centimeters as a ratio. Right? 2 centimeters. And rather than writing it as a ratio, I'm just going to write it as a fraction. Right? So every 2 centimeters was 115 kilometers. Right? So the way you set this up is you write the ratio as a fraction, and you're going to set it equal to, and I know the measurement from Vancouver to Calgary on the map is 17 centimeters. So I'm going to write 17 centimeters up top, and then on the bottom is where I put my variable x. Because these ratios have to be the same. Right? So this is the map ratio. This is the measurement on the map. Right? So just make sure the centimeters line up top. Therefore, the kilometers on the bottom. Okay? So this will not be flip-flop. Make sure the units are lined up. Right? Now to solve this, you guys have had enough experience over the years with this. Is you're going to cross multiply. So this becomes 2 centimeters times x, which is 2x. It's going to equal 115 times 17. Okay. All right. So 2x is going to equal. So let's just punch that into the calculator. 115 times 17 equals 1955. And then what we're going to do here is divide both sides by 2. These cancel. And divide that by 2. And we get 977.5 kilometers. Right. Cool. All right, guys. So that is, so that's scale diagrams.